Alright guys, so today in this video we're going to be doing something similar to you watched in the last video. So we're going to be identifying terms and like terms and being able to simplify this expression. So my game plan is I'm going to run through, similar to what I did in the last video, how to identify terms, how to identify like terms, and then how to simplify. And hopefully giving you another example will just help you learn it, help it make more sense to you. So in this example, what I did was I took instead of having constants in here, so obviously there are no constants in this example because every term has a variable with it. So now we're going to be able to go through and we're going to start off again by making our t-chart. So let's make the t-chart. I'll work on the left. Steps on the right. Alright, so the first step is going to be rewrite this expression with only, and hold on, let me put only in a different color. With only addition signs. So my goal is here, I want to take the expression that we have, and as you can tell, there are addition and subtraction signs in this, and I want to get rid of all my subtraction signs. So the way I do that is I look at the first term, z squared, and I say to myself, okay, there's no plus or minus sign here, so it's going to stay as z squared. Then I have an addition sign that comes after it. This addition sign is already an addition sign, so there's no point in changing it, so we leave it the same. And then we add our 5z next to it. Ooh, ugly. Hold on. Better. Next we have subtracting 3z squared. So again, we have to change subtraction to addition, so I'm going to do it in a different color. So we take the subtraction sign, we change it to addition, and then we make the number that comes after it, which is 3z squared, into the opposite. So the opposite of 3z squared is negative 3z squared. And then we add, oh, hold on, let me get this into black again. And we add z. Okay, so then we scroll down to our second step. And our second step is going to be, so we now want to identify, man, I just cannot write today. So now we're going to identify terms. So the way we identify our terms is our terms are always separated by addition signs. So we're going to list them. So when we list our terms, I'm going to write the word term, and then I'm just going to list them. And when I list them, I'm going to separate them with commas. Terms. So my terms here are z squared is my first term. The addition sign separates my first term from my second term, so my second term is 5z. Again, so this addition sign separates my second term and my third term, which is negative 3z squared. And then my last term, again, separated with the addition sign between my third and my fourth term, is just plain old z. So now, after we identify our terms, we want to go down and identify like terms. So the way we identify like terms, I'm going to call them LT. Like terms, I'm going to use two different colors. So like terms, when we talk about, they have to be two constants or two numbers without variables, or if they have a variable, they not only have to share the same variable, but the variable also has to have the same exponent. So the first term I'm looking at is z squared here. I'll circle it for you. So z squared has a z as its variable and a 2 as its exponent. So then we look through and we say, okay, 5z. This also has z, but are the exponents the same? Well, the exponent here is 2, and then this exponent here, as we talked about in my first example, is understood to be 1. So 1 and 2 are not the same exponent, so these two are not like terms. So that means we have to go to the next term. And we say, okay, negative 3z squared. They both share the same variable, z, and they both share the same exponent, 2. So those would be considered like terms. Then we move on to my other two like terms. And we say to ourselves, okay, so we look at 5z to the first, and we say, okay, the only other term here is z to the first. It's not a like term. So this is z. Again, the exponent here is in the top right-hand corner. It's not written, so it's understood to be 1. So the variables are the same, and the exponents are the same. So that means that they are like terms. Then in my last step, we simplify. And the way we simplify is we combine like terms. So we take our like terms, z squared, and we add it to negative 3z squared to get negative 2z squared. And then our other like terms are 5z, and we have to add them together. So 5z plus z, because combining tells you that you have to add. So 5z plus z is 6z. So then my final answer, which I'm going to write in black, is negative 2z squared plus 6z. And I know this is my final answer because there are no more like terms. And since there are no more like terms, I know that this expression is in simplest form.